3. So it says, a fish's tail weight is 9 pounds. Its head weighs as much as its tail plus half its body. Its body weighs as much as its head and tail. How many pounds does each fish weigh? When you read all that, yeah, it's a big jumbled mess. So you've got to take it in pieces. So let's just start with the first thing we're given. The first sentence here. It says, a fish's tail weighs 9 pounds. So I'm going to go tail is equal to 9 pounds. Does everybody understand that? Okay? So now read the second sentence. It says, now it's giving us information on its head. It says, its head weighs as much as its tail. So now we're going to talk about its head. So the head is equal to the same as the tail, right? 9 pounds. 9 pounds plus half of its body. So 9 pounds plus 1/2 of its body weight. 1/2 body weight, right? So everybody see how I set that up? Now it's giving us more information in the next sentence. Its body weighs as much as its head and tail. So now I say, okay, so the body weighs as much as its head and tail. So the head plus the tail, right? Does everybody understand that? Okay. So now what we're going to do is, so it says, how many pounds does the fish weigh? Okay, so once we know, so we're just going to use these to solve for each variable, basically. Okay, so first of all, don't we know if we plug in, so we can plug these in anywhere, first of all. So like this, the way I'm going to do it is different than I did it on here. Okay, so we know the body is head plus tail. So can we do this plus this? So let's write a true statement. We know B is equal to the head, which is 9. I'm just going to write 9 plus 1/2 B, right? That's the head. Yep. Plus the tail, so plus 9. Now look, in this linear equation, do we have just one variable to solve for? Sweet. So let's solve for B. So really we have B is equal to 9 plus 9, 18, right? Yep. 18 plus 1/2 B. So now you say, well, what do I do with B and this B? Well, you combine them using algebra. So I'm going to subtract 1/2 B from both sides. So we know that this is 1B minus 1/2 B's, right? Guys, 1B minus 1/2 B's is how many B's? 1/2 B. So we have 1/2 B's is equal to 18, correct? Okay, so now solving for B, wouldn't we multiply both sides by 2? Yep. So we have B is equal to 36, yeah? So it says, how much does the fish weigh? Isn't it 36 pounds since we found body? Yep. Okay. So wasn't that a lot easier than it maybe seemed to begin with? Yeah. So, and this is what's interesting. So I made it harder on myself the first time I went through it, and I solved for, I plugged in for B over here, and I solved for, then I plugged in, so I plugged in B into here, then I plugged in the T, and then I had all in terms of H, solved for H. When I knew H, then I added up H plus T, and I got 36. But that took a lot of extra work. Questions? So we know, it says how much does the body, oh, yeah. Yeah, right, how many pounds does the fish weigh? Doesn't the body weight of a fish, the head weight plus the tail weight? Okay, we're all good? Okay, so those problems on that page are all the same, like I started out.
So you want
No,
36
5.
plus the head plus the tail, it would just be 36? Because it does the
Try it for a second before you,
because it does the full fish.
what was that?
But when we plug the 36 in and added the...
Well, remember that body is the head plus the tail, so you wouldn't add up a head and a tail twice, right? So the body weight of the fish is the head weight plus the tail weight, so wouldn't that be the full weight of the fish? Does that make sense? Okay, we're all good? Okay, the rest of those problems are very much like that. Okay, so try them. Okay, moving on. So here's our first problem. This is a stage review problem. You need to write it down quick. It says, what is, and this is going to help you with the pages you're working on today. So it says, what is the vertex of the function? Is it a maximum or minimum value? So just write down that function real quick, and then we'll go ahead and do it. Okay, so it says, what is the vertex? Well, first of all, we have a quadratic, right? Everybody? There's like 10 different ways we can solve this, especially at this level. That's what's hard. There's like so many ways we can go about this. We could graph it, second trace, find the min, right? Second trace, find the min or max, whatever it is. And then, you know, left bound, right bound. But this is a lot easier for me. First of all, don't we know it's a quadratic? Don't we know the shift is right 2, since it's in vertex form, this is the easiest thing. Right 2, up 7, right? So right 2, up 7. So we know the shift, if we have a quadratic, will be right 2, up 7, and then want it be flipped upside down, because it's got -3 in front. So our vertex is going to be at, isn't that our vertex? 2, 7. That easy. Don't make it harder than it needs to be. So our vertex is at 2, 7. Questions on that? And then is it a maximum value or a minimum value, that vertex? Max. Isn't it the highest point? So this, and then we say it's the max. Questions? Okay, next one. Number 2 is asking us the same thing, but it is very different. It says, what is the vertex of the function? Is it a maximum or minimum value? So once again, looking at this, we have 2x squared plus 6x minus 3. Yeah. This is not in vertex form. This is in standard form. So to be honest, we could go through and complete the square and all that stuff. That's a lot of work. Let's just type it into our calculator and use it. So go y equals, let's all type it in. 2x squared plus 6x plus 3. Okay, graph.
It's -3, yeah.
Okay. Good catch. So I need to make my window bigger to see, because my window's not very good. So practice make sure you can see the whole quadratic. Okay, awesome. So now we'll do second trace. Isn't it a minimum, guys? Min, right? Lowest value. So when it says left, you have to be left of the min. Everybody practice so you know you can use your calculator. Right bound. Scroll right of the minimum, anywhere right. Hit enter again. Our min is at -1.5, -7.5. Now what if I didn't accept those as an answer? What if I wanted the fraction? Type in your calculator. Get out of the graphing and type in -1.5 in your calculator. Hit enter. Hit math, enter. So this is more what I'd like to see. -3/2, comma, and then -7.5. Hit enter. Divide math, enter. Right. And -15/2. Probably a little bit more exact. Okay. And then we knew that this was a min, because it was a problem like this, so it had a minimum value. Questions? Pretty easy. Okay, number 3, go, write it down. So this problem says, what is the vertex form of a quadratic? Remember, there's 2 forms of a quadratic. Standard form, ax squared plus bx plus c. That standard form, vertex form, is a times x minus h squared plus k. Right, everybody? So this is in standard form. We want to take it to vertex form. So we do that by completing the square. Now, first rule with completing the square is your a value has to be 1. Does everybody see how our a value is not 1? So let's factor that out. So we're going to factor out 4. Now, in huge parentheses here, that means I'll divide each term by 4 and see what's left over. So that's x squared minus 4x plus 2, correct? Okay, that's our first step. Now we can continue by completing the square. So completing the square is b divided by 2 squared, right, everybody? Don't forget that. B divided by 2 squared. So it'll be -4 divided by 2 squared, which is -2 squared, which is 4. Isn't that what we're inserting as our square? Yep. And we insert that in after bx. But you can't just insert a 4. You've got to add 4, subtract 4. So being really careful now. So we have this 4 on the outside. Then we have x squared minus 4x. Now we're adding our square, 4, subtracting 4 to even it out so that we're really just adding 0. And we can't forget about that plus 2. Is everybody comfortable? Questions? Please ask if you do. Then we group the first 3 terms and factor. Group the last 2 terms and add. So this factors to be, what multiplies to be 4, right? And adds up to be -4. Isn't it -2 times -2? which, look, remember the trick we learned?
Yeah.
So this is going to factor to be x minus 2 squared. And then what's negative? Negative 4 plus 2. Negative 2, right? But now here's the catch. We can't forget in parentheses this 4 was being multiplied. So we've got to multiply 4 to this and this. So 4 will go here, 4 will go here. So we'll have 4 times x minus 2 squared minus 8, right? 4 times negative 2. And now it's in vertex form. So guys, if you multiply that back out, you'd end up back where we started in standard form. Would I ever multiply, here's a question for you. Would I ever multiply 4 in and then square it? No, right? That'd be squaring 4. Is 4 squared? No. Okay, good. Okay, a couple more. We're almost done, and I'll let you work. Here we go. This is actually, yeah, so only 2 more. It says, what is the equal form of this quadratic? I'll let you write it down. Okay, it says, what's the equal form? So what kind of form is this in? Standard or vertex? Vertex, right? So isn't there a standard form of this? So my question is, when we simplify this, will I put this negative in, then square it? Yes or no? Absolutely not, right? The negative is not squared. So what we really have here is I'm going to have this negative in front, negative 1 technically, right? And then in big parentheses, I'm going to multiply out x minus 2 times x minus 2. Now that negative wasn't multiplied to the 3, so that 3 doesn't go in parentheses. Is everybody comfortable with how I'm doing my algebra here to ensure I don't mess it up? Now let's distribute. X squared minus 2x minus 2x, and careful, plus 4. So inside our parentheses, we have x squared minus 4x plus 4, right? Now the negative was in front, so we have a negative 1 multiplied to all of that. So that's negative x squared. Negative x squared plus 4x minus 4. Good, and then plus 3. So our final answer would be negative x squared plus 4x minus 1. Questions? Be precise. Awesome. Okay, number 5. This will be our last one. So the question is, how many and what type of solutions does this quadratic have? So how many and what type of solutions does this quadratic have? Now I could go through and solve the whole thing and then tell you, but that would take me extra time that I don't need to do. It didn't say what are the solutions, it says how many and what type. So couldn't we use the discriminant? Now remember the discriminant in the quadratic formula, x equals negative b plus or minus the square root of v squared minus 4ac all over 2a. Isn't this part the determiner if we have 2 real solutions, 2 imaginary solutions, or 1 real? Because if we have the square root of a positive number under here, wouldn't that be 2 real solutions? If we have the square root of a negative number under the radical, won't that be 2 imaginary? And if we have the square root of 0, isn't that 1 real solution? Because plus 0 minus 0, same thing, right? Okay, so let's calculate this part, the discriminant. That's called the discriminant, guys. Using this. So my a value is negative 3, my b value is 2, my c value is negative 7. From the discriminant, I know everything. So b squared would be 2 squared minus 4 times a times c. Let's see what that is. Not the square root of that. We know that that's under the radical. 2 squared minus 4 times negative 3, parentheses times negative 7. And we get negative 80. Our discriminant is negative 80, guys. So the discriminant is under the radical, right? So won't it be 2 imaginary solutions? Yes? Okay. That would be our answer. So if you know the quadratic formula, you know the discriminant. Because it discriminates against the answer. You can use that to discriminate and say, oh, we're going to have 2 imaginary without finding any of it. You're discriminating. You're making assumptions, but this is a good assumption. Does that make sense, everybody? Yeah. Because the square root of negative 80 would be I, right? So that's a good question. Does that make sense? So because it's negative under the radical, because the discriminant's the part under the radical. Yeah.
So what
Yeah.
is
Great question. So if it's positive, wouldn't that be two real solutions? Because the square root of a positive number is a positive number, right? So then you have negative b plus the positive number, negative b minus the positive number. So that'd be two real solutions.
What was the other one you said?
One real. Because if that came out to be 0, then negative b plus 0, negative b minus 0 is the same thing. That's why there's only one real.
If it's 0, it's 1. If it's 2 negatives, then it's imaginary.
Two imaginary.
And then if it's positive, it would be 2
Two real. Yep. Okay, this is what pages you should be working on, 15 through 19. You should be up to there.